next session, we'll do a panel discussion on why ZKPs will play a major role in the future for Web3. So we'll have speakers from Aleo, Alex, Adrian from Anoma, Rahat from Polygon, and Hyunok from Zkrypto.
And then I will be a moderator of this panel talk. I always want to make this GK meetup some kind of casual and funny, but always turned out that it's the most serious conference room I have been. So. Okay. I prepared some questions for these panels, but please raise your hand if you have any other questions. Okay, so first you can start a brief introduction of yourself. Firstly, Aleo, you guys know that one of the leading contributors to ZK open source, and then Anoma. I get to know Anoma and the teams that they published really great articles about the ZK tech, like one in 2020, I suppose.
Yeah, we were very early.
And then Polygon, as you can see, they released the ZK EVM, which is really cool tech in ZK space. And then Professor Oh, he's actually an advisor of Radius as well, and he's the only ZK researcher in Korea, I suppose.
No, there are so many researchers.
Okay, so, but as far as I know. Okay, so can you give us a brief introduction of yourself?
Yeah, hey everybody. My name is Alex. I'm the COO of Aleo. You heard a little bit about Aleo. So the short version is it's a platform for privacy preserving applications. So it's a completely separate ecosystem from Ethereum. It's its own layer one, taking a full stack approach to offering privacy powered by zero knowledge proofs. And then the only caveat that I had to what you said is all questions, I only want hard questions. I don't want any easy questions. So only throw hard balls for me this evening. Thank you.
Cool. Hey, I'm Adrian. I'm one of the co-founders of Anoma. I mean, I was given a great presentation about Anoma, so I'm just going to leave it with Anoma's unified architecture for full stack decentralized applications, and everything else was covered in the previous talks.
Yeah, I'm Rahat, developer at Polygon. So Polygon believes in building different scaling solutions to top of Ethereum, just trying to make it more accessible for folks.
I'm Anoma from Zkrypto, but also at the university. Our team is actually developing some work in progress and Zkrypto using the ZK-SEL and also the ZK-SEL itself.
Okay, I will start with the easy one. So, I founded this ZK-SEL in 2019, but recently it's really get attention. The ZK tech real some kind of great attention from developers as well. So please choose one thing that you said you think that a great improvement is. It makes it possible to get so much attention these days. Why now? Why not?
So I can start with that. First of all, I think why is this technology? Why is this a breakthrough technology in my opinion? I think, and I gave a talk about this yesterday at Asia. I don't know if you all saw it, but I think that the key thing for me is that before zero knowledge proofs, you had this tension between being able to verify something and being able to keep that private, right? It's like the example I use is a deck of cards. The example that I often use is a poker hand. If you're playing poker, I claim to have a royal flush. You ask me to show my cards, which is what you would need to do to verify that I have a royal flush before you're going to give your money to me, right? In ZK, though, in that paradigm, I can prove to you that I have a royal flush without revealing my cards, and it's kind of just this fundamentally new paradigm that enables so many different exciting applications. I think why is it relevant now? I think blockchains have been a boon to cryptography in general. I mean, I think yeah, I mean, the internet, of course, like, you know, has spurred a lot of interest in cryptography for blockchain, specifically because they're built from so many cryptographic primitives. I think really inspired an interest in ZK, and especially because zero knowledge solves some of the very fundamental problems with blockchains, namely the fact that typically things are transparent by default, which may not always be desirable. But secondly, you know, the scalability is limited, as we've seen, you know, things like Ethereum and Bitcoin that sort of rollups, and ZK rollups are looked at as possible solutions.
Yeah, so why now? I think the technology is getting exponentially better, and I think the major turning point there was actually the Zcash upgrade from the Sprout circuit to the sapling circuit in like 2017, 2018, where proof sizes went down from like 8 gigs to like 200 megabytes doable on a mobile phone, right? Like this was sort of, to me, the inflection point at which point it's like, holy shit, we can make this so efficient. This can live on every edge device out there. And then sort of the more broader reason for why now, I think everyone, probably in the audience here, feels, or at least I personally feel, is that the institutions around us are crumbling as we speak. Democracy is eroding at a sort of terrifying pace. And I think the privacy-preserving decentralized tech that we're building in this industry is really the off-boarding path from centralized institutions that are faded, collapsing around us without requiring like World War III. Because we kind of sort of, like to me, the decentralized privacy-preserving space is sort of the exit valve that we can fade over into as institutions around us crumble.
So if you want to prevent World War III, you need to adopt ZK.
Build cryptography, please.
Cool. Yeah, I mean, if we look kind of like back at like the business of Web3, like it started off with this promise of like owning your data, owning your, you know, your identity on chain or things like that. But if you, I don't think it's enough to just like own it. Like if it's on a public ledger, even if you own it, like anyone can look at it, right? So you kind of like have to take it to the next step of like, what do you need to know? What information do you actually need for your application? You need to know if you're 18 or over to use this application. I don't need to know your actual age. I need to know when you were born. If something like you're 18 or so it's like sharing specific bits of data. Like what do you need to know to actually let me use your application? Let me actually, you know, function properly in this whatever metaverse world thing you may have created. And still like actually owning my data because I don't need to share the actual data with you. And then just like adding all the scaling kind of like on top of that of like having these new experiences and ability to create new applications that work, you know, fully possible or scalable on, you know, blockchain technology as it was over the past couple years. So that's definitely what excites me most.
In my opinion, I mean, in the world of Web 2 case, I think the data communication or data sharing is most important. So in that era, the confidentiality is very important, which is that the encryption is very popular at the time. But nowadays, we are looking at the blockchain application, blockchain itself, it is providing the trust. Blockchain case, the integrity is the most important feature of the cryptography. So to provide integrity, I mean, the initial blockchain is using the digital signature, but I think ZKP, general proof, is actually the generalization of the digital signature. So you can do anything. It is a very powerful tool to provide integrity. So I think that's the reason why ZKP is very popular in the blockchain community. And also I think it can be used more area. Currently it is using the privacy preserving and also scalability, but I think it can be used more area in the blockchain.
Okay, let's talk about the privacy. Personally, I researched the privacy technology for like 5 years, including the privacy preserving machine learning, something like that. And then I believe that privacy really matters. But ironically, a few years ago, the Korean government banned trading of privacy-related coin at crypto exchanges. So there are some ways to respond to this. Is that some kind of green key that reveal certain hidden data to specific entities. So what would you say to like a Korean government for this situation?
Hey, you're only giving me easy questions. This isn't fair. No, actually, I really love this question because I think there is this sense, as you pointed out, especially from regulators and governments around the world, that, oh, it's privacy-preserving technology. Zero knowledge is privacy-preserving technology, and it's like encryption. And that's I mean, it's obviously it's a form of cryptography, but the applications, I think, are actually fantastic for regulators. In fact, I think, in my opinion, a future central bank digital currency, like the conclusion of the issuer of that will realize they need zero knowledge proofs because you don't want an economy where everyone can see everyone else's transaction. But the nice thing about proofs is, you can define what statements you're proving, and you can encode regulatory logic inside of that. And the nice thing about that is, if I'm sending money to Adrian potentially, like using a regulated stablecoin, you can have logic such as exists in USDC today, for example, which is like, okay, if Adrian's on a blacklist that someone has defined, I can't send him money. And therefore, if you're a regulator and you're overseeing a system, the transfers in the system, you know all those transfers are correct, at least as in terms of the laws as you define them. And you don't have to check, right? Because most people don't realize that banks today have gigantic compliance departments. They go through and manually check, and guess what? They miss 99% of the actual crime, right? So in many ways, I think this is a boon to regulators, and it's not something to fear.
Yeah, I think I have 2 points on that, which is, one, historically, we have combined the tech with the asset, right? Like when you think Zcash, it offers privacy for ZK. When you think Moderator, it offers privacy for XMR. But, for example, is Ethereum a privacy coin? And I would actually argue yes, because Tornado Cash exists on Ethereum. But this sort of, in the future, every asset will be a privacy coin because like the tech isn't tied to a specific asset. Like what we're building with Amada, I don't know if I spoke about it, is just like asset agnostic privacy guarantees. You can put your crypto pump into a shielded pool, and all of a sudden all crypto pump, like all assets in existence will become privacy preserving assets, because you can bring the assets to the technology. And fundamentally, we're going to split this apart that like tech and assets don't have to be fundamentally tied together. The second point would be that, like, especially in South Korea, actually, I think without privacy preserving tech, we will never get any sort of mainstream adoption, because what would happen if you move the South Korean financial system to public Ethereum tomorrow? Like, the next day, North Korea is doing a massive data mining over the entire financial system. It's like no one in their right mind is ever going to approve a transparent financial system because it's a massive national security risk. Like, I think the regulators that we most often speak to in the blockchain space are like the taxpayer. And yes, sure, they like everything private, everything public. But if you actually speak to the more security-minded folks, they go like, you know what? If everything is public, we are starting to have real problems that we actually, like, they need privacy tech for national defense. So I think the best pitch line for governments is privacy tech for national defense, or ZKPs for national defense.
Yeah, I really like the notion of privacy but verifiable. Yeah, because you have this layer of privacy of if it's a big creditor who wants to look at credit scores, who wants to give you some funds based on whatever your credit worthiness is, rather than going through giving them your entire life, they can verify that you do have this credit worthiness, you do have the ability to pay them back without needing so much information, right? And they can verify that you're private, and at the same time, it makes them not as susceptible to attacks, because you have so many of these different creditors who have had social security, in terms of in the US, social security numbers and things like that, and if leaked, had taken sort of wherever on the black market or wherever, and what if you could just verify these type of things without needing and having the need to just record all this information, right? So bigger kind of use cases of just all these centralized entities wanting to do kind of the work, keep your stuff private. It's kind of open up as possible for this type of thing.
I'm totally understanding the Korean government stand because there are so many attacks from the North Korea, maybe we're guessing, and they are trying to money laundering for their hacked money. So in order to regulate that kind of money laundering, I think the private preserving, the current private preserving like approach like ZK or Moderator will not be accepted because there's no way to regulate. But anyway, I think the current design of the privacy preserving token is just ongoing. I think using the ZK-SEL or ZKP is very easy to add more features, as Alex mentioned. So we can easily add regulation, or we can have another feature like, for instance, in the Azeros, there is an auditor who can open the all transactions for make the regulation. But I think in the future, there is some meeting point to meet the privacy and also regulation. So we are, I mean, it's kind of, we have to pursue the reasonable middle point for this privacy and regulation.
Sorry about that. Guys, back there. I will give you plenty of time for networking after this panel talk ends. So please keep your voice a bit down, please. Yeah. Thank you. Okay. I will just throw a really difficult question, but I don't have it. So I will ask you from the developers' perspective. The developers always said that I don't need a new language to learn. But Aleo, you have Leo, and then Zkrypto, you have Vampire, and then Polygon, you have kind of Solidity, and then Professor, you write code by yourself. So please tell that. What do you say to developers?
Yeah, so actually I don't like that characterization of developers that much, because I think most developers that I've interacted with and know are inherently curious. It's one of the things that brought them to being developers or engineers. They like languages. Certainly they had to learn at least one language to become developers. And I think, it's not about, and by the way, everyone who's an Ethereum developer had to at one point, like people used to say this about Ethereum and Solidity. And by the way, Solidity is a very small language on the spectrum of all programming languages. Let's be very clear. And so I think it's really, the onus is on projects like Aleo or anyone who creates a new language for something, is to show the utility of that language. And why is this cool? What is this useful for? And so, I think for us at Aleo, the reason why we have Leo is, the programming in ZK is hard. We could probably talk for an hour just about that, but just suffice it to say that it's a different model of computing than we typically think about. And so it kind of requires a different set of tools to do it well and to do it safely and securely and intuitively. And so that's the utility, that's the reason to build a new language from the ground up. Frankly, it's not really possible to write Solidity and have the Solidity compile into zero-knowledge. It's just not, it doesn't make sense, right? And so I think for me, that's the real utility of having a language. It enables you to access this technology without being a cryptographer. But it does require, taking a stab at something new.
Currently, writing zero-knowledge, writing circuits is tremendously difficult. Pretty much the way you do it is you hand write the constraint system in Rust. And so you're basically connecting gates, right? Like you're designing effectively a physical chip. You can kind of think of it this way, where you like draw wires between different gates and you try to write this in Rust and hope that it works. This is clearly not sustainable if we expect that we want sort of thousands of developers writing their own circuits. But the other thing is we need an entire compiler stack effectively to support circuits, because you not only want completely privacy preserving applications that are only circuits, you need the interaction between, you need to have some transparent, let's say WASM or Solidity, that transparently hooks into then a circuit verifier that then can understand the output. So you need a very high level language that can integrate over the entire system. And so to that end, we are building Vampire, which is actually, Vampire is not the high level language. Vampire is just it's a language to encode polynomials, and then you can define what kind of proof system you want to target. So you can say, I want to get a snark, I want to get a stock, and then the polynomials just map into the right circuits. And then on top of this, so now I'm talking about the compiler stack, sits Pruden, which compiles to Vampire and Wasm, which is a dependently typed programming language, so you can write proofs about the language in the language itself in the same program. That can output then circuits as well as transparent also.
Yeah, I mean, I definitely agree with a lot of Alex's question before. Like, most developers, engineers are very curious about the different technologies and things that they can learn. When I was a full-time engineer, I was very much, curious about all the different intricacies of this type of technology. So, I mean, I could say that, we have one solution, the ZK-AVM, for folks who may be more, comfortable just staying in Solidity or whatever. But, that's just our initial offering in the ZK kind of world. We've got, several teams working on other solutions as well. So I think it's important for, from a developer standpoint to definitely look at like what what technologies are out there, where you can grow, and where you can kind of like, if Solidity is your thing, sure, ZK-AVM is there, and as you kind of grow, learn other technologies, more solutions will kind of pop up as well. So it's important to keep up with all the different things that are happening in the world.
Okay. So in my opinion, before this ZK-SEL, actually in the hardware designing system, there was some trial to move from the hardware specific language to the hardware language like SQL. The reason why they are trying to do is that writing the circuit level design is very difficult and tedious, and it is generate a lot of error. But still, if they are moving to the hardware SQL and compiling SQL to generate the circuit level code, then the performance is not going to be enough. So that's why people are, the developers still stick to the low-level design. Currently, I think the ZKP community is a little bit similar situation. So currently, it is just beginning stage. So we are just concerned about the performance of the ZKP. So we are stuck to the low-level designing. So actually, we are using the JSON, which is a circular designing. Maybe several or some years later, I think more better tools coming out, and also productivity is more important. Then I think new language, new language is not going to be difficult to learn, actually, if the performance is actually enough.
And I guess just one super quick thing to add, I think, I completely agree with Professor Oh's characterization of high-level languages, sometimes you sacrifice performance in there, but I think there are also, as compiler architectures advance and get better, there are cases in the real world for other programming languages where actually a high-level language or a high-level language can optimize lower-level instructions in a way that the programmer himself couldn't have hand-assembled. Rust is a great example of this, where in some cases Rust programs run faster than native C code that it compiles to. Or if you just try to write the same thing in C. So I think I'm really excited as the compiler architectures that Adrian mentioned, that we're working on, that other teams are working on. As those advance, I think it's really going to be a boon for people who want to use this technology.
Actually, we are waiting for
I've always found it really difficult to debug and write code. So if you guys can provide some kind of debug language or
yeah, so for us, we have our own, so we're kind of taking a full stack approach and really trying to approach it from the developer first and then on down through the protocol. So we have a studio, called Aleo Studio, where you can write Leo code, and there's a debugger, there's some syntax highlighting. The other feature that I actually can't believe doesn't exist in most other crypto or crypto or blockchain languages or ecosystems is the ability to import code that others have written. I always find it really funny with safe math. It's like, I should import a library so I don't underflow or overflow an integer. And when you do, you can't import it, you have to just copy and paste it, right? It's very foreign if you come from a world like C or Python or whatever. All these modern languages have the ability to import code that is written without having to copy and paste it, right? So that's something that we have in the form of a program registry, so you can just import, you can literally just use the syntax import X circuit that someone else has written, and that automatically gets compiled into the R1CS. when the thing is synthesized.
Yeah, so for Vampire, I mean, Vampire is a very simple abstraction over just polynomials, so there's not a lot of tooling that can be built there at the moment. Jubix is a high-level language. It will eventually, I don't think currently will be powered yet. It will eventually happen. Oh, maybe one funny thing on like importing libraries. So Ethereum had this idea, and the one person that built Ethereum, Gavin, would try to use this and then lost $300 million when the underlying library got deleted. This is how the Polygon folks lost the first fundraiser income.
Got it. Okay.
So yeah, don't make libraries deletable. That's sort of the big takeaway from Ethereum.
Yeah, I mean, debugging is definitely a big thing in the, just in general in engineering. Misleading is definitely come very far in previous versions. Definitely a lot of the syntax improvements, a lot of tools that exist in different IDEs that, you know, give you a lot of like those, I come from like the JavaScript world, so I really like the TypeScript kind of like integrations that you have in IDEs like this code, and a lot of that is now available for flexibility, kind of giving you some of those like type-safe understandings of like how things work, using things like aspect comments to make sure that, you know, you're having additional level of safety in like whatever inputs or whatever you're doing in your code as you're going through it. So yeah, I mean, there's definitely a lot of different tools out there now to kind of debug in that sense.
Yeah, debugging on the ZKP problem is really hard. Actually, debugging on the cryptography application is really hard, I think. So even though the debugger is showing the every variables, actually there's no way to the computation is correct because I mean it's just if the cover addition, then we cannot compute whether it's correctly computed or not. So I think the tool of the debugger should be, if it is providing such kind of cryptographic operation features, then maybe it's helpful for developing the cryptography application and also ZKP application, because ZKP application, in the ZKP application, the most difficult part is actually debugging of the cryptographic application inside of the circuit.
Okay, time for the audience. You can ask any questions to these all ZKP experts. And then we have around 8 minutes to go.
Hi, I'm Kaylin. So what I understand is that zero knowledge proofs, so they sort of they're not getting rid of the transparency, but what they're doing is they're protecting that transparency. So what I understand is that this is very beneficial to mitigate MEV. And I was wondering about your perspective on how zero knowledge proofs can, what you guys are doing for MEVs, especially in cross-chain settings or multi-chain settings. So yeah, that's what.
I can start. Yeah, so quick, I think that's a great question. I love this question because I think it's really important because there's something, we've talked this whole time about why are ZKPs amazing? What's something that's not easy to do in ZKPs? And you know how to for anybody, if you want to really make somebody on the stage or anyone who's doing a ZK protocol squirm a little bit, ask them how they'll implement Uniswap inside of a ZKP. And you'll see people start, right, so basically these applications where you require concurrent access of the same state by multiple users, there ends up, even in the ZK scenario, there needs to be this concept of a sequencer, right? And so even though you have the ZKPs themselves, once the transaction is settled on chain, provides privacy. Someone has to, inside of the ZK proof, in the rollup case, for example, someone has to decide the order in which these things go. And so in that sense, for an application like Uniswap, MEV, you kind of just move the problem to a different part of the stack. Now, your presentation, Radia's presentation, their technology, this is like what they're trying to address, specifically using some different cryptographic techniques. Other than ZKPs are part of it, but there's a whole bunch of other cryptography used too. And I think it's a really interesting area of research. But I think that's one really important thing to remember about ZKPs is if there's multiple users or if there's any need to access things concurrently, there needs to be a sequencer to decide what order things happen.
Yeah, I would split this MEV protection from zero knowledge proofs, generally speaking. You can deploy, so what we're doing with Anoma is we have a distributed key generation protocol called Aleo that allows a validator set to hold a distributed public key. All transactions are encrypted against this public key, hence you only actually sort in blocks and define the ordering of encrypted byte string in blocks. And then on the next block, the validator set jointly decrypts all the transactions. Ordering can't be changed, so you can't front, back, or sandwich anymore. And this gets rid of single chain MEV. Cross-chain MEV, it's a totally different story that's going to be incredibly difficult to solve. This is sort of future research. On your point, for like building Uniswap privately, if you actually want to build Uniswap privately, you need to advance fully homomorphic encryption by about 5 to 10 years. Once you have shared, because the fundamental primitive that no one can, and you can't do better without this, is that to have shared private state, you need fully homomorphic encryption in order to make this work in zero knowledge proof. And to build something like Uniswap where you have multiple parties having access to the same state, you need this kind of shared private state in order to make this private in a zero knowledge setting. Right now, the best you can do is that you make the who private and the what public. So you can build like private Uniswap where Uniswap itself is public, but at least the sort of who's trading against it is private. That's like by far theoretically the best thing you can do.
So instead of buying more NFTs, donate to Professor O's lab so he can solve this problem.
Yes, it's FAG.
Yeah, on the Polygon side, we're kind of addressing this with a proof of efficiency model, consensus model that we have on the ZKVM. So, in that model, we have our sequencer kind of going through. The sequencer is just totally in charge of looking at transactions, making sure it's batched properly, sequenced and sent over to validation by the aggregator. So with that kind of like each piece of the puzzle is like focusing on a specific thing. Sequencer kind of does that within a proof of efficiency before it gets sent over to the aggregator, which actually takes care of the validation of this.
I think they are explaining about the transparency between the multi-chain. I just want to say about the multi-chain, cross-chain itself using the ZKP. Actually, as you know that there are a lot of attacking in the cross-chain. People are believing that the ZKP is also kind of a solution for this cross-chain problem. But still, to solve the cross-chain problem using the ZKP, a recursive snark or recursive thing should be accelerated. I think if we can do that, then maybe the cross-chain problem can be easily solved by the ZKP. So that is also another domain of the ZKP.
Okay, another question? You want to ask?
You may not see them behind the
actually I have a question for Adrian. So, as I had a chance to get to know a little bit more about the other projects, so I have a question for you. So those your project, does it involve the end user creating the ZK-SEL proof in their edge device? If yes, do you think it's reasonably possible for the end user to create a proof in terms of power efficiency and
so we have a very specific application here, which is Anoma, it's a single circuit that just provides multi-asset privacy to arbitrary assets. You can easily run this the proof generation on any modern mobile phone. It takes about 2 or 3 seconds. It's a ZK-SEL proof under Groth 16, so it's incredibly powerful.
which library are you using?
What do you mean library?
LN? Or what?
It's Groth 16 and Rust, so I guess LN. You can check out the code at Anoma/MAS.
2 to 3 seconds in all.
Okay.
Cool.
Okay,
Actually, you can think of it, it's, I'll tell you more.
okay, thumbs up. So this is the end of the ZK9. Thank you so much for coming to this event, and after this you can network in time, so question. Okay, thank you so much.
Thank you, everyone.